Hi friends, today's lecture is about AISC 360 16 code stability. Okay, so in this video, I will tell you about design for stability and what is the requirement to design these structures. Okay, तो यहाँ पे मैं आपको बताना चाहता हूँ, ये स्टार्ट करते हैं हम लेक्चर। सबसे पहले जो इम्पोर्टेंट है, डायरेक्ट एनालिसिस मेथड। ओके, इन दिस यू कैन सी द डायरेक्ट analysis method. In this you can see that in this direct analysis method to represent there are three chapters are available for this. First one is general stability requirements. General stability requirements. Second one, calculation of required strength. And third one is calculation of available strength. These three chapters are given in AIC 360 for stability purpose only. Designed for stability. Here they provide a note. Alternative method for design of structure for stability provide in appendix A1 and 7. Now, what is the requirement we have taken for general stability requirement? General stability requirements. For general stability requirements, what is the what is procedure we have to consider for this? So first one I am telling you about, the stability shall be provided for structure as a whole and for each of its element. Okay, the we have considered for general stability or whatever the we stability consider for whole or and each of its element. Okay, so this both we consider for our structure analysis or stability purpose. The effect of all of the following on the stability of structure and its element shall be considered. So first one, what we consider for stability consideration. First one, I am telling you about the flexural shear, okay, and axial member deformation. Axial member deformation. Okay, these 3 points we have considered if we design for stability. Then all the components and connection deformation that coordinate contribute to the displacement of structure. Second, B point, second order effect. Second order effect. So in this second order effect, we see in this second order effect, including P delta and P delta or P means delta and P gamma or P delta effect we have considered. Okay. Now third one is second order effect we consider. Then geometric imperfection. This is very important also. if we design for stability. Geometry, if everything is perfect and our structure geometry is imperfection, then the structure will fail. Then third point, stiffness reducing due to inelasticity. Stiffness reduce due to inelasticity. So this inelasticity, if our stiffener don't provide the elasticity to the member, then the stiffness also reduce the structural flexibility and structure will collapse. So this is very important points. Then fifth point E, we have considered uncertainties in system. Uncertainty in system. What type of uncertainty in system? The member we have choose, and the connection strength, and stiffness. So these uncertainties we have considered if we design for the stability, general stability of structure. Since all load dependent effect shall be calculated at level of loading corresponding LRFD. In LRFD, load combination is or 1.6 time ASD load combination. Any rational method of design for stability that consider all the listed effects are permitted. Okay, these all effects are including if we design for general stability of structure. So our first point are complete. In this, we can see methods. Okay. There are two methods available if we design for this general stability. First one is first one uh, direct analysis method. Direct analysis method of design. In this, we can see the direct analysis method of design is permitted for all structure and can be based on either elastic or inelastic analysis. There are two permissible, elastic and inelastic method available in this direct analysis method. Then for design by elastic analysis, required strength shall be calculated in accordance with section. Then second point, alternative method of design. Second point, second method, alternative method of design. In this, we can see in alternative method of design, the effective length method and first order analysis method. Effective length method. In this method, we have used effective length method and first order analysis method. These two methods are we have referred in this alternative method of structure. Both defined in Appendix 7 are based on elastic analysis. Okay, these methods are based on only elastic analysis. So this is difference between direct analysis method or alternative methods. Direct and elastic analysis and are permitted as alternative to the direct analysis method for structure that satisfy the limitations specified in the appendix. So you can see this is for direct analysis for both elastic or inelastic, but an alternative method, there is the first order analysis method are only applicable for elastic analysis of structures. So in this AISC 36016, page number 80, you can see the uh, clause C1. In that you can see the details C1, C2. Second one is calculation of required strength. So this is also general, very general important point I am telling you. Calculation of required strength. In this you can see for the direct analysis method of design, the required strength of component of the structure shall be determined from elastic analysis. Okay. This elastic analysis, in that you can see we have take this required strength of structure. Now the required strength, the analysis shall be include consideration of initial imperfection. Okay, whatever the initial imperfection is governed, we have considered in analysis. Okay, initial imperfection. This is then we have gone to the next point. This is theoretical point in that is considered. ये पूरे theoretical point है. मैं आपको एक थोड़ा सा important point बताना चाहता हूँ. सबसे important point है notional load. To represent imperfection. So this is notional load. Okay. The detail of this for structure that support gravity load primarily through nominally vertical column, wall or frame. Okay. In on a structure, the support gravity load primarily. In this we can see the gravity load. For this gravity load, we design for vertical column, wall, frames. So these three important components are fall in if we design for gravity load. Is it permissible to use notional load to represent the effect of initial system imperfection in the position of point of intersection of member in according with the requirement of this section? The notional load shall be applied to the model of the structure based on notional geometry. Okay. This is a very important point. The notional load shall be applied to a model of the structure based on nominal geometry. This nominal geometry, whatever the nominal geometry of our structure have, accordingly we have applied this notional loads. In general, the notional load concept is applicable to all type of structure. And overall, the second important point, these are used in imperfection Okay, imperfection. Initial system is imperfection, so for that we can use this notional load. In general, notional load concept is applicable to all type of structure and to imperfection in the position of both point of intersection of member and point along the member. But the specific requirement in section C 2.2BA and 2.2 BD, these are applied for these notional loads. Notional load, second point, in this you can see the first point, notional load shall be applied as lateral load at all level. Okay, this notional load shall be applied as lateral load at all level. Okay, this notional load actually they provide in lateral direction of structure. The notional load shall be additive to other lateral load and shall be applied in all load combination also. Okay, this there are two types. In these two types we can use. First one is notional load are additive. Whatever we apply the lateral loads in that we can this load also we have add or this additive lateral loads. And second point we have applied to all load combination. So these 2 points we have generally considered for notional load. Here the formula given by ASC AISC 360, the Ni is equal to 0.002 alpha yi. So here alpha is equal to 1 for LRFD if we apply LRFD method, and alpha is equal to 1.6 if we use ASD method. So this difference you can see, Ni is nothing but notional load applied at level I. These are unit keeps N. Second one, Yi. These are gravity load applied at level I. From LRFD load combination or ASD load combination. And this unit are keeps N. Okay. नाउ हमने जो है पूरे पॉइंट्स मैंने आपको कवर करा दिए. ये जो नोशनल लोड से बहुत इंपॉर्टेंट रहता है, ये जनरली जो है लेटरल डायरेक्शन में आप अप्लाई करते हैं स्ट्रक्चर के. इसको जो अप्लाई करने का जो फॉर्मूला है, ये नोशनल लोड अप्लाइड एट लेवल, जो भी लेवल में हमारे को अप्लाई करना है, 0.002 इंटू अल्फा. अल्फा जब हम मेथड यूज कर रहे हैं LRFD, then we can use the value 1. But if we use ASD method, then we can use the value 1.6. Okay. Or here you can see this Ni is Yi is nothing but gravity load applied at level. Whatever the gravity load applied, gravity load means vertical load applied at the level of at this level where we calculate notional load, we have um, assume that value and we multiply with 0.002. Okay, these are given in AISC 36016. Okay, 2B. Now second point, this is A, notional load shall be applied, and you can use this note. The use of notional load can be lead to additional, generally small, fixtures based shear in the structure. The correct horizontal reaction at the foundation may be obtained by applying the additional horizontal force at the base of structure, equal and opposite in direction to the sum of all the notional load distributed among the vertical load carrying element in the same proportion as the gravity load supported by those elements. The notional load can also be lead to additional overturning effect which are not fictitious. So this is generally note we have provide. Second point, B. In this B point, the notional load at any level Ni, the notional load at any level Ai, Ni shall be distributed over the level in the same manner as a gravity load. The notional load shall be applied in the direction that provide the greatest destabilizing effect. Okay, so this is very important point. Keep in mind, this notional load shall be applied in the direction that provide the greatest destabilizing effect. So whatever the load destabilize the structure, then we have used this notional load. Very important. For most building structure, the requirement regarding the notional load direction may be satisfied as follows. For load combination that do not include lateral loading, yeah. If in that load and not type of do not have lateral loads, then we can use this lateral notional load. Consider two alternative orthogonal direction of notional load application in a positive and negative sense in each of two direction. In the same direction at all level, the load combination that include lateral loading apply all notional load in direction of result in all load combination. Okay, this is very important if we apply the notional loads. The notional load coefficient 0.002 in equation. So this is nothing but based on nominal initial story out of plumpness ratio 1 by 500, where the use of differential maximum out of plumpness is justified. Okay, why we use in this formula 0.002. So for this, it's a AIC 360 16. I have give you some explanation. This coefficient 0.002 are we have taken because the nominal initial story out of plumpness ratio of 1 by 500. So we have considered this, that's why we have used this coefficient. The out of plumpness 1 by 500, the AISC also give why they use 1 by 500. This out of plumpness 1 by 500 represent the maximum tolerance of column plumpness. Okay, this is maximum tolerance maximum tolerance on column plumpness. In some case, other specified tolerance such as those on plane location of column will govern and will require tighter plumpness tolerance. This is very important if we consider the notional load of our structure. For structure in which the ratio of maximum second order drift to maximum first order drift for load combination 1.6 times the ASD, then we have used the load combination and not in combination that include all the lateral load. Adjustment of stiffness. So how we adjust the stiffness? Now I will give you some example how we adjust if stiffness. So it's very important topic. Adjustment to stiffness. Now for this, the analysis of structure to determine the required strength of component shall use reduce stiffness. A factor 0.8 shall be applied to all stiffness that are considered to contribute to stability of structure. What the factor we have used for modify the stiffness, the 0.8. Okay, apply to all the stiffness. It is permissible to apply this reduction factor to all stiffness. Okay, this is a reduction factor. Apply for stiffness, and this apply for all the stiffness. This applying the stiffness reduction in some member and not other can in some case result in artificial distortion of the structure under load and possible unintended redistribution of force. This can be avoided by applying the reduction to all members, including those that do not contribute to the stability of structure. Okay, so if we apply this stiffness or we modify that stiffness with the help of reduction factor, then whatever structure have represent, we apply this reduction factor. If all the member provide the stiffness to that member, then we provide the reduction factor to the all the stiffness member. But if some member all member have stiffness, but we applied this reduction factor to the some member and we do not apply it to the others member, then it provide to structure to artificial distortion. Artificial distortion will happen in the structure. So this consideration of reduction factor is important. But when and which member to consider this reduction factor we have considered, this is very important. Okay, now you can get this point. In additional factor shall be applied in flexural stiffness of all member whose flexural stiffness are considered to be contribute to the stability of structure. For non-composite member, tau B shall be applied. Okay, there are different conditions we have taken for the this adjustment to stiffness. These are covered in AISC 366. If you want to detail, then we can take this in lecture. Now, the third point, calculation of available strength. How we calculate calculation of available strength. Okay. Now you can consider this point. For the direct analysis method design, the available strength of member and connection shall be calculated in accordance with the previous chapter D. Okay, in AIC 360 gives the effective length of for flexural buckling of all members shall be taken as unpressed length unless a smaller value justified by the rational analysis. Bracing instead to define the unbraced length of member shall have sufficient stiffness and strength to control member movement at the brace point. Method of satisfying the bracing requirement are provided in Appendix 6. Okay. The requirement is not in Appendix 6 are not applicable to bracing that including lateral force resisting system of overall structure. So this very important point I will clear in this how we calculate this buckling length. For that we have justified the we have considered this effective length for flexural buckling of all members. So these points we have clear in this video. The what we consider and what we uh, cover in this lecture. These all points are important if we design any type of steel structures. So this is first order, second order, the second geometric stiffness, imperfections, direct analysis method. So this is all important for stability purpose. So you can go through this video and I hope you enjoy this video. Please like and subscribe, share my video to your friends and colleagues and your means relative, and we have met in another lecture. Okay.